All right, let's talk about one of the most important ideas in all of modern programming, classes and objects. Now, that might sound a little intimidating, but trust me, we're going to make it super simple by building a house. Not a real one, obviously, but we're going to use an analogy that makes this whole powerful concept click into place. So, here's the game plan. First, we'll look at a really common coding headache known as spaghetti code. Then we'll see how a simple blueprint can solve it. From there, we'll use that blueprint to build something, run into a little problem with making identical copies, find a clever solution, and then finally, we'll figure out how to make our code actually do stuff. Okay, so first things first, why do we even need this stuff? Well, every programmer sooner or later runs into this exact problem as their projects start to grow. See, when you're just starting out, you kind of just write code, and it works, which is awesome. But as you keep adding features, things can get really messy, a tangled web where everything is connected to everything else. And programmers have let's say, an affectionate name for this: spaghetti code. Because, well, it looks like a plate of spaghetti. And this is the real nightmare. Working with code like this is just so frustrating. You try to fix one tiny thing over here, and suddenly two other things you thought were totally unrelated just break. It's just not a good way to build anything serious. So we need to stop cooking spaghetti and start drawing up a proper blueprint. And that brings us to a much better way of thinking about code, a whole philosophy called object-oriented programming. It's all about organization, and it starts with one simple, beautiful idea: the class. The easiest way to think of a class is to just picture a blueprint for a house. Seriously, it's not the house itself, right? It's the plan. It's the design that describes everything about the house: how many rooms it's going to have, where the doors should go, all of that. It's the master plan. And you've got to get this distinction because it's super important. You can't live in a blueprint, can you? It's just a drawing on paper. A class is the exact same thing in code. It's the design, the idea, not the final thing you can actually use. For that, we have to start building. So, just like a house blueprint would spell out all the key details, a class defines what we call properties or attributes. For our house blueprint here, the properties would be things like, its address, the number of rooms, and how many doors it has. Okay, so we've got our blueprint all drawn up. Now comes the exciting part: actually building something real that we can work with. And this is where the object finally enters the picture. An object is the actual physical house that we build based on our blueprint, the class. It's the real thing. It's what you can interact with. In programming terms, it's the piece of data you can finally use. And this right here, this is the real magic. Think about it. If you're building a whole neighborhood, you don't draw a unique blueprint for every single house. No way. You create one master blueprint. That's our one class. And you use it to build hundreds of houses, or objects. This is why it's such a big deal. It's how you write code that you can reuse over and over again. But, like in any good story, our plan hits a little snag. There's a big problem with just building 100 identical houses from one really specific plan. Just think about it for a second. What if our blueprint didn't just say, this house has an address, but it said, this house is at house number 123? What happens then? Yeah, you end up with this mess. Every single house we build, Hamza's house, Nazam's house, they all end up with the exact same address. This is total chaos. A package for Nazam could show up at Hamza's door. In the real world, and definitely in our code, this is completely useless. We need unique houses. Thankfully, the people who came up with this stuff were pretty smart, and there is a really elegant solution to this problem. It lets us mass-produce things from a blueprint while still giving each one its own unique touch. So say hello to the Constructor. You can think of it as a special part of our blueprint that acts like a general contractor. When you say, hey, I want to build a house, the Constructor is the one that gets the call to actually do the work. And the cool part is, you can give this contractor special instructions for each job. So here's the process now. When we ask for a new house to be built, we also hand over some unique info, like, hey, build this one at address number 456. The Constructor takes that unique address and uses it during the build. And boom, a custom house is created. Problem solved. Now Hamza's house can be at 123, and Nazam's can be at 456. Perfect. Okay, so our houses are great. They've got unique properties like an address and rooms. But they're kind of boring, right? They don't actually do anything. They just sit there. What if we want our objects to perform actions? Well, that's where methods come in. A method is really just a function that belongs to a class. It's a behavior and action. It's not just about what an object is, it's about what an object can do. Let's go right back to our house analogy. The house has properties, sure, walls, rooms, windows, but it also has a doorbell. And a doorbell isn't a property, is it? It's a thing that performs an action. You can ring it. That action, that's a perfect example of a method. In code, it would look a little something like this. We take our specific object, our specific house, Hamza house, and we tell it to perform the ring bell action on itself. And what's the result? Ding dong! We've told our object to do something, and it did it. All right, so let's do a super quick recap. The class, that's your blueprint. The object, that's the actual house you build. The constructor is the contractor who puts it all together using your unique instructions. And a method is an action that house can perform, like ringing the doorbell. That's it. That's the core idea. When you really step back, you realize these aren't just little programming tricks. They're the absolute foundation for pretty much all modern software. We started with a blueprint for a single house. But just imagine the kinds of massive, complex, dynamic cities, the apps, the games, the entire digital worlds that you could design and build once you start thinking this way. So the only question left is, what would you build?